Good day, class, and welcome to MLT channels. Today's subject is mathematics, and the topic of discussion is logarithm. You are welcome on board. Without wasting time, let's quickly dive into the details. Today, we shall be covering the quotient rule of logarithm. And what's the quotient rule of logarithm saying? The quotient rule of logarithm says that if you have log p base a divided by log q base a, that will give us log p minus q base a. So now let's start. In order to start, let's assume we have a number a which is equal to the power of x, and let this a raised to power x be equal to p, and we call this equation 1. And also we have a again, but this time around is raised to the power of y and is equals to q. Let's call this equation 2. Then what are we doing with equation 1 and equation 2? We are taking logarithm on both sides. So if we take logarithm on both sides, we have log a raised to the power of x equal to log p. And also we also have log a raised to the power of y equal to log q. Then we take base a all through. Don't forget that we are working with a number a, so we are also taking base a all through. And let's call this equation 3, and let's call this equation 4. So we are now simplifying equation 3 and 4. And what are we doing in equation 3 and 4? We are bringing this x and y, we are bringing them down. This x, we want to turn them to the subject of the formula, as well as this y. In order to do that, we'll need to apply the exponential law of logarithm. We have to apply the exponential law. And what's the exponential law saying? Exponential law states that if you have log x raised to the power of n, then this will be equal to n log x. So this will make our powers, which are x and y, in equation 3 and 4 respectively, to be x here and y here in equation 3 and 4. It will make them to come down. Then we cannot make them the subject of the formula. So now let's continue from equation 3. So we are applying the exponential law now, and equation 3 will now turn to x log a base a then equal to log p base a. Then let's call this equation 5. As we have done for x, we also do for y. This y will also come down. Then when using the exponential law as well, we have y log a base a equal to log q base a. Then let's call this equation 6. Now we apply unit law on equation 6 and we apply unit law here on equation 5, and we also apply unit law here on equation 6. That will eliminate the coefficient of x, which are log a base a, and turn them to the subject of the formula. So what is unit law of logarithm saying? The unit law states that if you have log x base x, log x base x, that will be equal to 1. So that's what we are applying now. We apply that here in equation 5, specifically at the left hand side, to turn log a base a to 1 here, and we do the same thing on equation 6 to turn log a base a to 1 here, so that we can have our x as the subject of the formula. So if you apply the unit law now, x will be equal to log p base a, because log a base a would have turned to 1, and if we multiply 1 by x, that still gives us x. And let's call this equation 7. This is what we want to achieve. We want to derive expression for both x and y. Then y also here will be equals to log q base a. And let's call this equation 8. We are almost there. We have been able to derive expression for x. So we make x the subject of the formula, and we have also make y the subject of the formula. So the next thing now we are supposed to do is to combine p and q. Don't forget that is what our number a raised to power a and a raised to power x are respectively. So combining p and q, we say p divided by q is equal to p in equation 1 is equals to a raised to power x. So that will now be a raised to power x divided by, then q in equation 2 is equals to a raised to power y, a raised to power y. Then if you apply division rule of indices here, we have a raised to power x minus y. So we have gotten our equation now, which you can call equation 9. So our equation 9 will be p divided by q equal to a raised to power x minus y. So let's call this equation 9. So what are we doing in equation 9? As usual, we'll take logarithm on both sides. So we take logarithm on both sides, we have log p divided by log q equal to, don't forget we are taking it on both sides, log a raised to the power of x minus y. Then we are working with base a, so we apply base a all through. And let's call this equation 10. So what do we want to do with equation 10 now? What we want to do with equation 10 is we apply exponential rule here. We apply exponential rule here so that x minus y can become base, they can come down. So doing that, we have log, let's move here a little bit. We have log p base a divided by log q base a equal to, now this is now what we want to achieve. We want to bring this down, x minus y, I want to bring it down using the exponential rule which we have stated here. This exponential law, when you have log x raised to power n, that will give you n log x. So applying that here now, so if you apply that there, that will make x minus y to come down at the right hand side of equation 10. So we have x minus y now log a base a. Then again, let's call this equation 11. What do we want to achieve with equation 11 now? We want to eliminate log a base a. This is what we want to eliminate. We want to eliminate log a base a. And to eliminate log a base a, what are we supposed to do? Now to eliminate log a base a, we apply, this is what we want to eliminate, log a base a. To eliminate this, we apply the unit law. The unit law here that says that log x base x equal to 1. So applying that in equation 11, that will give us equation 12. So we have log p base a divided by log q base a, and that will now be equals to x minus y, and let's call this equation 12. Now we are almost there. The next thing we need to do now is we substitute for both x and y in equation 12. And what are we substituting for them? We are substituting equation 7. In equation 7, we have already gotten what x is, which is log p base a. Then also the value of y in equation 8, which is log q base a. We are substituting those two values in equation 12. And in doing that, that implies that we have, let's use another ink now, because that will be our final answer. We have log p base a divided by log q base a equal to, look at the value of x. X is the value of x, log p base a. So that is what we substitute for x a. Log p base a, then minus, look at the value of y. Y is equals to log q base a, and that's what we substitute for y in equation 12. That will be log q base a, and this is what we are trying to achieve. This is our quotient rule. Here's our quotient rule. Compare this to what we have earlier. We want to prove that log p base a. This is what we want to prove earlier. We want to prove that log p base a divided by log q base a equals to log p minus q base a, and that's what we have here now. Because if we should factorize this, then that will give us our final answer, and this is equation 13, and equation 13 is the final answer of our quotient rule. Question easily done. Alright, 15 minutes just gone on, like 15 seconds. At MLT, excellence is our symbol. For inquiries and booking, you can contact Engineer Oladipo on 080 670 76871, or better still, you can visit our head office at Omega Building opposite Gasland Nigeria Limited, Obafemi Awolowo Way, Malete, Ibadan. And you can use our website also. We are on www.wordpress.mlttechspace.wordpress.com. Until I come your way again, I remain my humble self, Engineer Oladipo, your host and your amazing online tutor. Bye for now.